Okay, so today is the last day of trigonometry. Absolutely amazing. I don't like trigonometry at all. But today is the last day of it, and also I should turn my volume off, my volume down a little bit because I re-listened to my videos, and it's annoying to have this high of a volume. So it's turned down, right? I turned it down when I said it. So anyways, the law of cosines, or the cosine rule. I should put cosine rule as well. Cosine rule. So that's the two things, right? So the law of cosines or the cosine rule. And the law of cosines is c squared equal a squared plus b squared minus 2ab cosine c. And there's a reason why I boxed this. If you box this and you see, this is exactly the a squared plus b squared equals c squared you've learned since year 8, 8th grade, 6th grade for some of you. This is the Pythagoras' theorem, the Pythagorean theorem. And then there's this extra part that's attached to it, minus 2ab cosine c. I won't get into the specifics of why that's attached to the function yet. You'll probably learn that in analysis or something. I don't want to get into the specifics because it'll confuse a lot of you. So and it's also pretty easy. It's also a pretty easy predicament, though. That's the thing. It's pretty easy to prove that there's a minus 2ab cosine c. But the reason why it's out from the a squared plus b squared is a little bit of a mystery. So we have we have this triangle right here, and you guys know this triangle. You guys know the angles already, but we're just gonna try to solve for it using this formula right here. So let's try to solve for this angle right here, right? Theta. So then we'll have the formula will give us, that's 4 and 8, right? So c squared, 4 square root of 3 squared equal 4 squared plus 8 squared, and then minus 2 times 4 times 8, which is minus 64 cosine of the c, cosine of theta. And then you have 4 squared plus 8 squared, that is 80, and 4 square root of 3 is 48, and that's equal to minus 64 cosine theta. So if I take minus 80, go to the other side, you have minus 32 equal minus 64 cosine theta. And that will give you cosine theta is equal to 1 over 2. 1/2. So theta equal cosine inverse of 1 over 2. And this is cosine inverse 1 over 2. If you lower the unit circle, it's either 30 or 150. But we already have a right angle, so it's automatically 30 degrees. Or pi over 6 radians. So since this is 30 degrees, we can automatically conclude that this is 60 degrees. And no, excuse me, it's not 30 degrees, it's 60 degrees. Cosine of 1/2 is 60 degrees, and it's also 120 degrees, but it's a right angle, so it's automatically 60. So this is 60 degrees, and this is 30 degrees. I'm sorry. There you go. Because it looked wrong on the picture, and it is wrong. So 60 and 30. So this is a classic 30, 60, 90 triangle we had, but I just basically tried to solve for the angles using the law of cosine. So that's how you can use the law of cosine. And there's a Heron's formula, and well, no, the why it works part. This is another thing that you're gonna be learning. Maybe in your class, maybe not, but it's called a Heron's formula. And the Heron's formula is this guy in Greek. He created a way to prove to get an angle, the area of a triangle, using only 4 things. Using the semi-perimeter. S is semi-perimeter, so half of the perimeter. Yeah, and I can't spell semi-perimeter. Okay, and then A is A, B, and C. That's obvious. So we had a triangle of, I don't know, 3, 5, and 7. Our total area would be the square root. Area would equal square root of 7.5 times 7.5 minus 7.5 times 2.5 times 4.5. That's our total area, right? 7.5 times 4.5 times 2.5 times 4.5, which this will be around that's around 3.75, that's around 8, and that's around 36. So around 36, which is around, it's around 6 centimeters units squared, right? That's the area of the place. That's the area. That's the area of the triangle. So they're about 6 centimeters squared, probably a little bit more, but I'm not going to calculate. I'm also going to be doing these approximations for the next ones as well. So would you use the law of cosines or the law of sines to solve this triangle? I would use the law of sines, but I would not use the law of sines. I would use the law of cosines because I have two numbers and I have an angle, so it fits perfectly in my c squared equal a squared plus b squared minus 2ab cos c, right? If I have this 2ab, right? Oh god, that's ugly. Cos c. This, that's the a, that's the b, and that's the angle c. Done. Right? The angle has to be in between the two angles, by the way. The two sides. So if you don't know if you don't know the terminology, it's the side is opposite the angle. The side would actually, I'm really bad. I'm kind of brain dead right now. You could tell. But the side's opposite the angle. So C right here, A is right here, and B is right here. The side's opposite the angle. The names for it. So let's use Huron's formula. This is Huron's formula to find the area. So 14, 17, and 13. We'll have the square root of 14 plus 17 plus 13 is 44. Share 2 is 22. So it's 22 times 22 minus 14 times 22 minus 17 times 22 minus 13. Right? That's pretty not that nice of numbers. Not that nice of numbers. So we can get the 9 out, we can get the 3 out here. So this, we're gonna calculate the exact area. We can get 2 squared out, and then we have 55 left. And so the final area is roughly 2 squared is 4, so 12 times the square root of 55. Or the area is could also be expressed as roughly 90 centimeters squared, right? Let's work this out now. 28, 19, 20. So that will be 17 is equal to semi-perimeter, which is 25, 28, that's 67. So 33.5 is a semi-perimeter, 67 over 2. And 33.5, that's 5.5. And these 0.5s, I don't like 0.5s. So I'm just going to be pretty much approximating them. 14.5 and 35, that's 13.5. So we have, in total, we have this times this, which is about 196 multiplied by this, so around 990, 980, and then multiplied by this, so around 980, and then multiplied by this, which will give you around 32,400. So I'm going to say this is roughly, the area is roughly 180 centimeters, 180 centimeters squared. Yeah. Okay. So what about this? We have 71. 71 share 2 is 35.5. So that is going to be inside of our Huron's formula. 35.5 multiplied by 6.5 multiplied by 8.5, 9.5, and multiplied by the humongous 19.5. So we have 6.5 multiplied by 9.5, that's roughly 63. So yeah, that's roughly 63. 63 multiplied by 19.5, that's about 1,260 multiplied by 35.5, so that's around 1,260 multiplied by this, that's around 35, so that's 384, 63, so about 45,000. 45,000. So the square root of 45,000, roughly 213, let's say 213, about 213 centimeters squared. These are all approximates. I'm not rounding my answers in yours 10. I'm literally approximating all of these. This is probably plus or minus 20 off. This is probably plus or minus 20 off as well. This is probably plus or minus 10 off. So yeah. the the real thing that you should know how to do it. If you know how to do it, you will be able to do it. If you can just put everything in a calculator, right? It's not that hard. If you know how to do it, you'll be able to do it. For example, now we're gonna solve each of them. We're not gonna find the area anymore. We're gonna solve the real triangle, right? So we're gonna solve this triangle first. Let's say that's let's say that's A. So in order to get A, we have to do 14 squared equal 23 squared, 23 squared plus 25 squared minus 2 times 23 times 25. 2 times 23 is 46 times 25 is 1150. So 1150 cosine cosine A, I mean. So 23 squared, 25 squared, 23 squared is 529, 25 squared is 625, plus 529 is roughly 1154. So 1154 subtract from 14 squared is about, wait, this is 196, so 1154 minus 196 will give you 950, minus 958. Minus 958 equal 1150 cosine A. So if you divide by minus 1150 both sides, you will have 958 over 1150 equal A, equal cosine A. And so A is just going to be the inverse cosine of this 958 over 1150, which is roughly, I'd say, about 20 degrees, about 25 degrees roughly, right? So this is about 25 degrees. If you want to do this, you gotta do another iteration of the cosine rule, which I really don't want to do, but I'm going to do anyways. Yeah, I'm gonna do it. We have 23. We have 23 and 14. 23 squared is 529. So 625 is equal to 529. Let's say this is B. 625 is equal to 529 plus 196 plus 2 times 23, 46. Now 192, 652. Cosine. Oh no, this is minus. Minus 2 cosine B. And then we'll have this is equal to 725. 725. Subtract, you have 100 equal minus 652 cosine B. So then B is equal to 100 over 652 and cosine inverse of that. That is roughly about 2 over 11. So that would probably be pretty high, about 85 degrees, give or take 5 degrees. Yeah, that'll be pretty high. So this is about, let's say, 85 degrees. So then you can solve for the other one, which is 180 minus 25 minus 85. You'll get your 70. And that's it, right, for that triangle. For this triangle, I won't solve the whole thing. I'll just solve the side, right? This one is actually nicer because then you can just do c squared, or c equal to the square root, right? C equal to the square root of 13 squared plus 28 squared minus 2 times 13, 26 times 28, which is 676 plus 56, which is 732 minus 732 cosine of the 39 degrees that I put down, which will give you 13 squared plus 28 squared is about 169 plus 784, 793, 953 minus 732 cosine 39 degrees. And cosine 39 degrees, if you look at the thing, it's square root of 3 over 2. It's about in the middle of square root of 3 over 2 and square root of 2 over 2. So the value is roughly 0.75, let's say. 0.75, so 3/4. So we can actually make this 583 minus 953, which comes out to be a pretty nice number. Not nice number to square root, but a nice number to it's just subtract, right? So 370 is roughly 19.2, 19.2, 19.3. So give or take plus give or take plus or minus 0.1, right? And so this is the final question. You have to rewrite this law of cosines right here, but you have to rewrite it using c as when c is a right angle. So let's see what will happen when c is a right angle. So we'll do c squared, right? Not c the side, c the angle. So c a squared plus b squared minus 2ab cosine c. But cosine c is cosine 90. What's cosine 90? Cosine 90 is 0, correct. So 2ab times 0 is c squared equal a squared plus b squared. And what is this? What's this formula? What's this formula? It's the well-known Pythagorean theorem, right? And I just drew a 3, 4, 5 triangle to showcase that it is a Pythagorean theorem 3, 4, 5 triangle. And the cosine is 90 degrees, because if I use the cosine rule, if I use this law of cosines in the 3 and the 4, and I had this cosine to be 90 degrees over here, I could figure out the 5. I could. And if I use the cosine rule on this one, I could figure out, right? So 4 squared equals 3 squared plus 5 squared minus 2 times 3 times 30. And then we have cosine of the b, and then we would have 16. This is 9, this is 25, so that's 34. Subtract it over, you have minus 18 equal minus 30 cosine b. So then the cosine b would be 6 over 10, right? Cosine b 6 over 10, so b is roughly cosine inverse of 6 over 10. And if you look on the unit circle, 5 over 10, 60 degrees, and 7 over 10 is about 45. So 6 over 10 is around 37 degrees, give or take 2 degrees, right? So if this is 37, this is 53. There you go. You've solved the 3, 4, 5 triangle. See, the law of cosines when c is a right angle is really, really useful, right? And Huron's formula, obviously, if you take this triangle and you do the Huron formula, you'll have a square root of 6 times 1 times 2 times 3, which will give you square root of 36, which is equal to 6. And 3 times 4 divided by 2 is 6, right? And if you do so we know 3 formulas. We know the 3 formulas for the area of a triangle now, which is 1/2 base times height. We know the Huron's formula, s minus a, s minus b, s minus c. And we know the area of a triangle formula, which is 1/2 ab sine theta. And those are your 3 area of a triangle formulas, right? We know more ways to calculate the area of a triangle than the perimeter, but with the perimeter you can just use the law of cosines and sines. That's why trigonometry is so well built, right? And that's going to be it for trigonometry. We will be you are done with all of the numbers for integrated math 3. You will be now going into statistics and geometry to end the course. So and then we'll go to calculus, obviously. So I'll see you next time for choosing the right model, I think.